everyone. Really great to be here today. We'll be speaking about how to really use generative AI to build tools within a company, to automate things, to make things operation more efficient. It will be a really hands-on and technical talk, so do not hesitate afterward if you have some questions to elaborate on it. Okay, what is VP? So VP is the French unicorn founded in 2001. Today we have 3 billion turnover in sales across Europe, 5,000 employees, more than 30 million active members daily. And what is more important about this is that we digest every year 5 million products. 5 million products from roughly 7,000 brands, ranging from sports to a garden to appliances to anything you can sell, we sell them on VP. So these 5 million products, we need to produce them. So we need to build the technical sheets, the images, we need to shoot them. And this is how actually VP was built back in the days. We were really a digital factory for brands. So the cornerstone of all the operation within a retailer generally is the product classification. Why is that? Because it structures all your operations, pricing, logistics. So if you have a manual process for doing this, you will be prone to a lot of errors in pricing. So you will price a product wrongly, meaning you will have a leakage of margin. You can have, for example, a broken competitiveness on a given categories. As you know, e-commerce today is highly price sensitive and competitive. For finance, all the reportings, the tax filings, etc., depends on the product taxonomy. So you need to be sure that they are well done and correctly. And if you have wrong taxonomy, you will get for wrong reports, budgets, etc. So the pain is big. For logistics, imagine you have classified a product as a T-shirt and now it's a dishwasher. So it's really a big pain for the logistics and the fines you can have afterwards on the chain. So really, when you do manual product classification, it can be slow and prone to error, and the huge downstream is really big. Why is it a problem? Actually, we have tried internally to automate product classification with machine learning. We have tried for 6 years. It was not successful at all. Why? Because you have categories which are not messy, so they are not mutually exclusive. So you can have T-shirts and tops. A T-shirt is a top. So what is the difference between the two categories? You cannot change them because it structures all the company. So you have a huge latency when you decide to modify them. These categories are also evolving constantly. If you have a new product in the market emerging, you need to capture this trend and include it in the taxonomy. You have a great imbalance between the categories. For example, for the millions of products we sold from 2001, we have like 3 times the 3D printer. So you have a category 3D printer with 3 products in the historical of the product management system internally. And you have what we call a cold start problem. You define a category, but you don't have enough data to qualify it or to learn on it. When you check what is the success rate, the quality of the data today we have in the catalog, we have roughly 11% error. So even existing data cannot be used to really train a model efficiently and to scale a classical classifier. So what we need to build is kind of a zero or few-shot classifier. And this is a press of how we engineered such a system and why is it useful. So the classical approach for this kind of classification to do what we call a zero-shot classification using a CLIP model. A CLIP model is a multimodal, multilingual, it can be multilingual also embedder, where you have all the categories. So let's say we have 1,500 categories on the left. For each category, you transform it to a sentence saying, okay, this product is a T-shirt, is a car, is a tire, etc. You encode, you embed the sentence, you have a vector. So you have, let's say, 1,500 vectors. You take your product, which is an image, you encode it, and you compute the 1,500 similarities. It can be Euclidean similarity, cosine similarity, etc. And you take the top one. So with this, you have built a zero-shot classifier without training a model. You take a standard model on open weight model like CLIP, and you can build this kind of classification system. It's great because you don't need fine-tuning nor training, so you can make it work from the beginning, just the label of the categories. The embedding is fast, it's highly cost-effective, it's really peanuts. And the key feature is that we If you go further in the engineering, we not only embed the category, but we embed all the metadata of the category. So if you have expert knowledge, you can include it also in the embedding. Bad news, it's not that great. So the top one performance of this classifier is only, let's say, 58% accuracy, where the human accuracy is at 89. Top one, 58, and it increases up to 89 for the top 15. So if you take the top 15 categories, the most similar categories for each product, you will hit the correct one. So it's not really an automatic classifier. It will be a human assisted or need another system to be completely working. Second iteration of this algorithm would be, okay, we have the first system, which will yield, like, let's say, top 30 categories. We will add another system, which is, we will take a product, which is an image, we embed it, and we compare it to the historical products we run in VP. So we know that on the millions of products we play every year, we can select 1.5 million products that are correctly manually labeled, and we know that the classification is correct. So we will do like a search, a KNN. From this product, we will take the, let's say, top 100 products that are similar on the database, and we will take for these 100 products the top 30 categories. We merge the two categories using a very simple way, which is RRF, and we will get the top 15. What's great is that we will vote more for the categories that are similar to this one, making the algorithm better. So when we compare exactly the same metric, which is the top 15 category, we exceed the human performance. So we are now building a system where the shortlisted categories shown by the system will always include at least the right category and will exceed the human labeling done during operations. This is great because it captures the business logic behind. It introduces a historical bias within the algorithm, which is in this case good because we are introducing the same bias of operations. So we are mimicking what people have been doing for years in this kind of approach. And the cost, of course, remain really small. Okay, now the third step, so how can we go further? So far, it was not really a generative AI, so how can we introduce Gen AI to get a good algorithm for this? So we do exactly the same approach for the first layer, which is, okay, we combine the two methods, we can get the top 15 categories because we know that the rate of these top 15 is already great at 96%. And then we take these top 15 categories, we add the product images, technical sheet, and the label book. A label book is detailing in a human language, saying, okay, this category, it includes this kind of sub-products, and if we have this business rule, so we write like a recipe, which we would give to humans, saying, okay, if you put a product in this category, why and how. So we take all these 15 categories, all these inputs, and we put it in a multimodal LLM using structured output for the classification. Then the LLM, what will it yield? It will yield like a structured object, a JSON, containing the reasoning and the category itself, which should be one of the 15 displayed before. And in this case, we will have a top one accuracy of 94%, which is exceeding the human performance. It's great. Why? Because for the training, we don't really use model data to train a model. All this pipeline is zero shot, so we don't use a fine-tuned model or a model where we inject a lot of clean data where we need to balance between the categories. It's completely few shot or zero shot all along the pipeline. We use models that are publicly available, so you can use OpenWeight's model, you can use for the LLM and for the clip part. And what we are expecting with that is that if we add a new category, it's immune to the cold start problem because we'll embed the categories and include in the top 15, which will be also an option for the classification. So we don't really need sample data for each category. For the modality, we use text and images. But if you want to use the text, you can adapt the pipeline. It's exactly the same. It will work good also. Bon, the accuracy will be lower, of course, because you will have less information. And we can identify new elements in the taxonomy without the images. For the cost, the embeddings are really cheap. If you scale to 5 million products a year, it's completely doable, and the ROI is high. So it's fast, flexible, low cost, and it will allow you to adapt very quickly if the market has new product categories to include. Thank you.